Hello and welcome. I'm Bill Wake. We're here working on a transition from an old parser to a new one. We have this goal. We've got a basic interpreter that was built using recursive descent. We want to switch to the parser combinator approach, and in this case using the strategy pattern. We did it earlier using a more pure evolutionary approach, but the strategy pattern is nice because it gives you some reversibility. If you don't like the approach, you haven't changed all your existing code. So the strategy looks like this if you haven't seen it. Or if you have, the core piece is this syntax analyzer in the middle, and it owns a strategy. So it owns a way of doing something. So you initialize it by giving it the strategy of type parsing. And if you call function 1, then you call it delegates to strategy.function1. And if you call function 2, delegates to strategy.function2. Now the concrete parsers, old parser and basic parser, the syntax analyzer never refers to them. It only refers to the generic type parsing. And so it's independent of the parsers. And in fact, in our tests are independent of the parsers too. They don't care which parser does the job, just that, feed in this input, get this output. There's also a little bit of setup involved. Somebody has to decide which parser we're going to be using for now. And so I'm imagining a client of some sort or a setup of some sort, and it has an action to set up the client. It decides which parser, and then it feeds it into the parser, basically setting up those objects. And this is typically a one-time thing. It may be one per user session if it's a web application of some sort. Each person might get a different one. It may be something that's once per run, or something like that. That's what we're doing here. We don't switch parsers in the middle. We just say choose the parser at the beginning. It's almost hard coded in effect from their point of view of the rest of the system. They're always just talking to the strategy. They don't care what got put there. All right. And then in our transition for this, we've been working, and we've done all the statements, except that some of them call expression, and expression is still an old style parser. These are all in the new style now. And so I want to focus today. First I want to do a little wrap up on the statement stuff, but then move into handling expressions. And we haven't done any of these yet. So notice expression calls down through a big stack of things that basically reflects the precedence levels. So if you're not super familiar with grammars, when you have something like 3 plus 2 times 4, the 2 times 4 gets calculated first. Excuse me. That's saying because the precedence level of multiplication is more than the precedence level of addition. And an easy way to do that in your grammar is just to have multiple layers, one layer for each precedence level. There are other ways to do this, but that's the way we did it. It's kind of the most straightforward to write by hand. It might be nice to put in a parser that understands precedence, but we didn't do that. Now, the other thing to notice on this is expression goes down through all these levels. It gets down to factor, and then on the far left, parenthesized expression. Well, you put parentheses around a whole expression, so it points back up to expression. In other words, there's recursion involved. Same thing for variable. A variable can include an array reference. So a sub 3, okay, 3 is just a numeric factor, but it could be a sub 2 times 3, in which case it's, it could be any expression in there. So those two, function calls too, but all those, they make it recursive because they can reference expression again. We've taken a restriction. It's not real. It's an artificial restriction, but I've said that I'm not going to let old code call new code. I'm going to let new code call old code. So this recursion will have to deal with it a little bit. We'd already did in statements once. What we found was you can, if you leave the old statement processing tree around until you get that bottom level done, you can deal with the recursion that way. So coming in, you come in through a new expression or new statement, and when you hit a recursive statement, you call the old original for a while until you can replace it. Okay, so let's see. So first step I want to do is extracting statements to a new file. So let's go to Parser, and I don't know, this may not pay. All right, at any rate, we've got this function, make statement parser, and it builds up a huge statement parser. Okay. All these pieces are grammar rules that feed into it, a little bit of references to some semantic rules, but that's the whole parser. You can see a statement as assignment, data, def, dim, end, and so on. Okay, and let's find a wrap-old. Well, I think we only have one in that method now. Oops. Okay, yeah, we had the expression parser. Okay, I'm going to move this thing up. Okay, and actually, I want to separate this out. Let's look at the way we set things up. So we have the notion of different kinds of parser, statements parser, single line parser. Actually, the single line is the higher level. Let's do it like this. And then they get set up here. We call make statements parser and make single line parser. I'd like to make an expression parser too. And let's set it up the same way. For expression parser, bind, it parses tokens and it produces expression. Okay. And let's see, we need to set that up. We don't have this routine, but we're going to extract it from the other. Is it not? Okay, doesn't want to do that. And we don't want a local variable, we want the field. Okay. So I'm saying make expression parser. Ooh. Oh, we need to bind it. Okay. Is bind token expression. And then the parser is going to be wrap-old self expression dot parse and that. Okay. So our bind, you can either create it empty, or you can pass in a parse function to do it. So wrap-old self expression is the original parser, and we're binding it in from its parse method. Okay, and we'll just return expression parser. I think how did we do that here? Oh, let's just say, oops, I think that's still behind. Let's just say return this. And we make the assignment up here. Let's try build. Probably should have run all tests. Okay, what's the problem? Oh, I didn't initialize it. Oh no, I needed bang. So the exclamation point says, it sort of says it's optional, but I promise there will be one. And since I'm setting it up in the constructor, I trust that the rest of the uses can be fine. Now, I'm not understanding. There are rules for when you have to use the exclamation point and when you don't in the usage of the expression, but I'm not seeing any complaints here. But sometimes you might have complaints, and you have to put the exclamations in at the call site as well. I need to look that one up. There's something going on there. I don't quite understand. All right, but see here we're using expression parser. Now we've got that initialized in the constructor, and we're free to reference it in these other parsers. Okay. I don't tend to like to do things this way, but I think it will work out. It works out better in this case. Um, it's nicer if everything is side effect free, but it's okay to reference fields once in a while. Okay, and let's update this while we're waiting for that. So I would say we're in the middle of updating expression. Okay, so everything is good. There it is. Okay. So build expression parser in the constructor. Okay. And I guess if we try and extract, can we extract the statement parser? Let's give it a go. I may toss it, but it's worth a try. So we'll make a file for statement. Whoops. That's fine. Now statement. Probably statement parser would be a better name. Okay, and I want to take a bunch of stuff. I may need, well, what are we going to need? I'll need this. Won't need that. Okay, so let's cut this much. Well, let's copy. I think we'll copy first and then deal with it. It would be nice if I didn't have to, but Swift just isn't that sophisticated. All right, so I'm going to get this giant parser thing. It's going to have some stuff it depends on. But let's copy these two. Okay, so now I have make statement parser. And it needs bind. Okay, that's because we don't have pcombo. Parser library. Index of. Oh, this is a problem. So the token is the function name. Now, if I can get rid of token, that's probably a good thing. Okay. Match expression parser. Match an expression parser. Okay. That looks to be the bulk of it. And I don't know. Let's go here. I mean, this is used there. I don't want statement parser to depend on. I don't want a circular reference, so I'm going to pull this function down. It may put in a small bit of duplication, but I think I will live with that. Okay. And I don't know, when I say make statement parser, let's see, what do we reference? Just getting it out of the way is going to be an advantage. Okay, so statements parser makes single line parser. Those are the two public functions in here. Make statement parser. Did I pull and match? Yes. Okay. This one, I think the fact is oh no, it isn't. I'm going to come back to this one. Index of, this may be the thing that breaks it. The index of is referencing the position in here. The token doesn't know its position in that sense. It just knows, it knows its line number and column, which is interesting, but do I want to, how badly do I want this? I could give tokens their position. That might be interesting, to the token position in the line. And then I could just pull it out of the token. That actually is kind of a good way. All right, what else we got? We got rid of a bunch of problems. Cannot find expression parser. Okay, where is that coming? I think, well, I think we're going to give this thing a field and an initializer. Okay, so let's get expression parser. We'll take a copy of this and we'll make an init. Okay, so we said we will pass it in when we construct a statement parser. That helped a bunch of these. Require float type. Require float type. Okay, a lot of require float types. Is it enough? Cannot find line number and range. Statements parser. Okay. You know, maybe that should come in. Let's do this a different way. Let's pass, let's pass the expression parser into the function. Statements parser. Okay, so we're going to say make statements parser takes the expression parser and require matching types, require float types. Member type 4. Okay. Let's, sorry, finish the thought here. Okay, and let's go down to statement parser. Single line parser, let's pass in a statement parser. Okay, then we need some requires. Let's see, we require matching type. We have this one. Require float type, require matching type. I believe those both work this way. Whoops, what did I just do? Okay. Index of token, max line number, that's a constant up top. Index ofs, okay. And type 4. Another one I think we could get rid of with a little more work. An index of. Let's go see line number and range. Okay, so he's really only given that. I can eliminate that one. I can't get rid of the other one. Okay, so this one, line number and range. Well, remaining is the input after the line number. So we know remaining's index -1 is the index of the token. It doesn't solve the other one though. Okay. Well, let's make, oh, we can't build. I can't really get to that index of unless I get back to this basic parser. Unless I put those token, I can put them in the tokens. That's a little longer, a bigger step than I want to take right now. Do we have the tokens? No. Where's the Lexer? Okay. Token, Lexer. Okay. Oh, actually token. So token holds the line number, the column number, but it doesn't have like the index. It would be nice if it did. I mean, that would actually be helpful. A little more locator information. All right. Let's dummy that out for now. Okay, and okay, so index of is a numeric. So function index of token is an integer. Let's return 1 for now. And I'm going to add that to my to-dos. Actually, we may save that. Let's see. Make statement parser dot index of pull value from the token itself. Okay. This well, it should still run because we're not calling it. Okay, now I got to make sure I do this right. Okay, so if I build my expression parser, I want to say let statement parser equals statement parser. Okay, now I want this to be statement parser dot make statements parser, passing in expression parser, and this one is statement parser dot make a single line, passing in statement parser. And make sure that type is right. Make statements parser bind token statement array of statements, and make single line statements parser bind token array of statements. Okay. The trick with this is, well, the place you can fall apart. Yeah, what's going on? Oh, okay. The place you can fall apart is if you end up creating partly on basic parser and partly on statement parser, it's going to become a mess. I think this is okay now. Okay, let's run this. I think I've been good. Oh, def error message. Okay, that function name may not be fallback. Unknown statement. Well, that's not a very good message. Why did that change coming from there? Let's go look at def parser. Match the def, then match function. Def requires the name of the form. Function X. Okay. And then, well, what def x9? So it should have gotten to x, and then the 9 should be problematic. Def function cannot be followed by extra letters. Okay. The question to me is, why is this acting different now? Okay, required variable parser. Match variable, variables required. Okay, fine. Okay. So it should have been okay. Right parent. Okay. We got the equals. Yeah, so the problem is we're only allowed a one character variable, and that gets caught in here. But it seems like it's, well, is it something about the token of? So token. You know, the statement is going to be line number 0, def 1, function 2, token 3. Let's return 3 here. I think the 1 is letting it it looks like it's no better than anything else, you know, because it just failed right away at 1. 0 was the line number, so I think let's try this. We're definitely a little kludgy, grant, but I think we have successfully swapped that in. Okay, so let's save that. Create statement parser. Move functions over from basic parser. Okay, we haven't actually moved them yet, or we still have the old ones there, but we don't need them. Okay, so now in the basic parser, I should be able to get rid of a number of things. Certainly this. Make expression parser we still need. Make statements parser. It's all this stuff. Okay, make single line parser. Yep. Okay. That's our entry point is parse. Let's move that up to the top. Actually, let's move these down. Okay. It builds. And it should run. Okay, and then let's make sure, is anybody using, well, match I expect to be used in this file. Just once, huh? Oh, when, okay, that's pretty much match. Okay. Who calls this? Parse calls single line. Single line is single line parse. Okay, fine. Match line number and range. I think that may still be needed. No. Oh, the only ones that would need are stuff like go to. Okay, type 4 I think might be used by the variables in the expressions. No. Okay. Require float type. I may leave this one here. There definitely is usage of it. Right now it's using this, but I think in the end it's gonna not. Okay, let's see if that still works. Okay, so we deleted functions, already moved to statement parser. Good. Okay, so now we're ready to do the expressions in earnest. Okay, and so I've got expression. I want to, let's see, what do I want to do? I guess I want to pull in the or expression and then move that. I'm going to leave this expression around because those ones on the bottom that reference it. But I can match the or expression. So my version of expression, instead of wrapping old expression, well, expression just calls or expression. I can wrap old or expression. So let's find our make expression parser. And I'm going to move that closer to where we're working. It'll move over anyway to a separate file. So let's put it in the neighborhood. Okay, so here's expression. Okay, so let's let parser equal. I'll do the extract first. Run that. And so I'm calling expression, but in effect I'm going to inline it and call or expression. Okay, and that is good. Okay, so make expression builder call or expr instead of expr. Okay, now expression is actually a funny thing. So I want to say let result equal bind, and it's a token to expression parser. I'm not going to say what the parser is just yet, but I'm going to do it down here. Okay. I'm going to say return, or no, I'm going to say result.bind, parser.parse. Take the .parse off here. Okay, and return result. Okay, so I am creating an expression parser. I'm not filling it in with anything because it's recursive. I need a way to refer to it recursively. Is this going to work? Well, this will be okay for now. I'm not sure in the end. Okay, we'll work with it. I think maybe I need to call it expression parser, but okay. So this is okay. Parser bind. This should all work. It shouldn't. It puts a it puts the bind on there, but that's okay. All right. So introduce delayed bind with expression parser. And I don't know, maybe fix some names or something there at some point. Okay. Now, I think things are more straightforward. So this thing, the OR parser, let's see, OR expert parser, OR expert parser is, all right, well, it's going to be an AND parser, wrappled and expr. And then it's, oh, I always forget self on there. Okay. Now, the rule for this is you create an AND expression separated by ORs, and then you require float types and build it. So the separated by ORs, well, let's put it on, is this, and we're going to ignore the ORs because we know they're there. Is separated by token OR, so match OR. Okay, so you've got AND expressions separated by ORs, and then you need to check their types and build them. Okay, and this, all right, the result of this is it's an array of AND expressions. So let's do, Now the problem with required float types is if it's a string and it's just a string could be the result of an AND expression, but if you have any ORs, you need to require everything to be floating point types. Now we're getting an array of stuff back. We're not getting a piece at a time. So I think we're going to need a function for this. And it's going to be a lot like this function. Well, the header's going to be a lot like it. Let's borrow it. Okay, expression or expression. I'll just stick that here for now. This is like form expression. And maybe it's form numeric. No, they're not numeric. Well, let's start with form expression. Okay, and we're getting in a bunch of expressions, which is an array of expression. Remaining is slices of tokens. Yes, parse result is token. I think this is a result that produces, let's see, expressions, what it produces. So that's going to be expression. Okay, so the expression operator produces expression. That part's right. It parses tokens, and the contents are all messed up. Okay. So I guess if expressions is always at least one, so if expressions.count is 0, we know we've got a success. What do we have to return? The expression and the remaining. Okay. Expr sub 0 and remaining. Okay. So if there's only one expression, that means there were no ors, and the one expression is the result of forming the expression. So that's fine. So now we know there's at least one, and they've all got to be numeric. Okay, so let's see. Can I do this here? I want to say if expers dot all satisfy float. What do we got? Require float type. Require float type expression. Okay. This is too complicated. Okay, let's do let's call this one old. Old. And we'll make a new one. Actually, it's so simple, maybe we don't even need to. Expert type equal number. Okay, if they all satisfy expert $0 dot type equal number. I guess this is really more of a guard. Guard. If, well, no, I want to guard. Oh, I guess I do. Guard experts all satisfy numbers, else return dot failure. And that's this. So it was in the content of the expressions. We're not being super precise here, unfortunately. But type start index number and the error. No, it's actually the floating point error. Oh, numeric type is required. Okay, so I make sure if there's only one item, we return it. If there are multiple items, we make sure each one is numeric. Okay, and assuming that's the case, then we want to, we're going to return a success. Now, the value we want to return, well, I guess I'll break it out just because it's a little. Result equals, now we want to take the expers dot reduce initial result I guess we want to do expers dot, is it drop first, reduce, and then expers sub 0 is the first item, and the result expression maybe I don't need parens there. Result expression in, and now I want to do dot op2 dot or result expr. Okay, so we're building up a tree of these things. Notice that the first one is the first, the second one is the second. That builds a little subtree. That sets left to right precedence, and that should all just be okay. Return success with result and remaining. And there. Okay. So I'm going to pipe that thing through form expression. I lost something somewhere. Whoops. Success. Expected. Am I messing up right paren somewhere? That one. That one. Drop first reduce. Oh. Can do it like that. Cannot convert expression. Array of expression to parse result token expression. Array of expression, parse result token expression. They look compatible to me. Parse result token expression. That's an array of expressions. That's an array of expressions. Let's see what it thinks it is. Separated by keep left. Wrap old expression. Well, that should be an expression. Huh. And that should be, I mean, if I say, let's see what it's saying again. Cannot convert value of array expression to expected argument type. They say this backwards. It's really can't convert value of separated by keep left, wrap old, blah, 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 array of expression. Well, let's try that up here. I thought they were identical, but maybe not. No. Huh. Cannot convert array of expression. Oh, array slice of token. Where's that coming from? Remaining. Oh, wrong operator. Okay, pipe is only for pure conversions, but we want to do error checking, so we need this one. Okay. Well, should still run because we haven't used it. We're just trying to get it right. Okay, but now op2, op left, op is the token. Oh, somewhere there should be token type. Well, we hard-coded it to or. I'm probably making things worse for myself later. But let's put this in and then we'll deal with that later. Okay, so there's my OR parser. So let's do this. OR expert parser. Now parser takes the place of that. I don't know, this is kind of redundant. OR expert parser, I could just pass or expr parser here, the wrap old self or expr is now this. So I think that should be good. Parser. Okay. This should work. Famous last words. Okay, extra characters, end of line. Column 7, 0, 1, 2, 3, 4, 5, 6, 7, A is not equal to end of line. Okay, what about you? Expressions. I don't know, those, let's just do simple parser tests. Start here. Assign string to number fails. Numeric type is required. It's not equal to type mismatch. That's actually okay. I'm going to take error message changes if they're at least, pointed to the same place, and this type mismatch is the same as numeric type is required on the variable. That's okay. Ish. Standalone string, numeric type is required. Yeah, everybody thinks it's required. Okay, let's go back. Oops. Back this way. Okay. We take and we intersperse the ors, and then we check form expression. Okay, down here, we take and we have or and express, so that's and with ors interspersed. Then we check the required float types at the end and the op too. Let's see, can we find a simple mismatch? Well, that message is better. Okay. Predefined return type. Numeric type is required. That is definitely not true. It's like this is not getting it. 2513 0 1 2 3 4 5 6 7 8 9 10 11 12 13. It's something about a recursion. Let's see, basic parser. I think we can close this one for now. This one. Okay, let's take one more look at it and then revert it. Wrap old and interspersed with match ors gives us A or B or C or D. Form expression comes in. It checks if the count is 0. Oh, that should be a 1. If it's 0, then that'll never happen, and it'll come in and try and do this. That's why we're getting numeric type all over the place. If it's 1, then expr sub 0 is actually legal, so it never is 0. So this line never got executed. Okay, I'm feeling better. There still might be some numeric type required popping out, but like I said, I'll take an improved message. Yeah, I will definitely take that. Numeric type is required. Actually, it would almost be better here too, but we haven't done and yet. Okay, I think this will be okay. Yeah, that's good. Okay, so we extract or expr parser. All right, so I think I would say we've done or expr and expression, and we're going to pick up on and expr. And let's take this. Okay. Now it's where I pay for the shortcut I took. Okay. Basic parser, and we've got or expression parser. Okay. And let's call this result or expression parser, even though it's what we're returning. I think it'll make things more clear. Okay. Now, and this, we have to leave this one around, unfortunately, because this is where that mutual recursion comes in. All the old ones that call, oh no, wait a minute, who calls or expector? No, maybe we don't. Yes, we do. All the old ones are calling expression right now, and that ends up calling or expr. Okay, so I have to leave these for now, but we can do the same. Basically, I mean, this is going to be so close, it's kind of silly. And expr. Well, and expr is really, it's the same shape. It's trying to do negation separated by and the token type and this require float types. All the rest is the same, except this thing was too smart about, oh, you're going to be doing ors, aren't you? So it hard-coded that. Really, array of expression is not the right thing, and I'm going to fix that. Okay, so let me comment out this for a minute. I mean, I knew it when I did it. I don't know why I didn't just do it right. Okay, make expression parser. No, form expression. Okay, really what this needs to be is expr token exprs. Okay, and it really is an expression followed by a pair. Well, no, it's followed by an array of a pair of token and expression. Okay, so the or would correspond to the token. Okay, and then the parse result, token expression, parse result, token expression. That's okay. I don't know why that's complaining. It shouldn't complain here. Expected comma. Insert. Thank you. Okay, I got parens messed up, I guess. Yeah, expression pair this. Okay, so it's an expression and then token expression repeated. Okay, now if, well, let's break it apart. Let expr token exprs equal expr token exprs. Now, if token at exprs.count is 0, okay, now we return expr with the remaining. Okay, so we're going to pass the tokens in, so we're not an array of anything anymore, or of a single thing. We have to get the first expression and then the array of all the tokens. So and that comes, you can see that here, this thing is now going to be, give me the tokens back. Okay, and that says pass those into the form expression, and form expression is ready for them. Okay, but we have to say this is, well, expers.allSatisfy. It's really token expers. Token expers all satisfy. Well, $0 is the token, and well, let's write it this way. I think we're getting a token exper. We're going to ignore the expression in token.type is number. Okay. And we also have to make sure that exper, sorry, it's not the token. The token is and, we know that. So it's exper in exper.type equals number. And the original exper.type equals number. And, okay, so we had to split things up. The first expression has to be numeric now, and the remaining expressions have to be numeric as well. Okay, let's format this a little better. Okay, if the token expressions all satisfy, their expressions have numeric type, and the first one is numeric. Okay, now we don't need to do the drop first thing. We can just say token expers dot reduce. Well, the first expression is the first one, which is by itself, exper, and then we get a result, which is an expression coming in, and this one is a token exper in, and then we're going to say let token expression token exper equal token exper, and then this is return op2, not or, but token dot type result an expression. Okay, I think that error will go away. Good. All right. This only affects the or expression for now, but let's make sure it works. Good. All right, so we make form expression handle arbitrary operators, change its interface to take expert plus array of token expert. All right, I think that will do well. And now our and expression, that should build. It should be happy with form expression, negation, matching, and oh, meant to pass the token in. Okay. All right, and let's pull that thing up into our expression. And expert parser. Now this can use that. Okay, so or expers and expers separated by ors, and then form an expression. Okay, and these form an expression. It's perilously close to duplication. We might be able to do something about. Run tests. One failure. I think it's a numeric type thing. Yes. Yep. Okay, that is good news. Okay, so we've tested both sides now with string and numeric on an and statement. Okay. We'll probably get the same result on these other operators, which is actually progress. I think it's a better message. These two, there are circumstances where you can say, well, you can say $B equals $C or $B greater than $C. That's legal. They're matching types of string type. But the problem is really times is not defined for strings. Okay, but that should work. Okay, make new and expert parser. All right. We'll move on to negation. And my goal is to get down to this bottom as quick as I can, which is going to take, a lot of the rest of the session. But once I'm down here and I get rid of these ones that reference the recursive call, I can delete all those intermediate layers. So that'll be cool. All right, negation. And also, we've been going for an hour now, so let's go ahead and take a break. Just a 3-minute break, and we'll come back and tackle the next parser, which I think is negation parser. And negation. And this one's our first unary one, so it'll be a little different, but we'll get there. All right, see you in about 3 minutes. All right, welcome back. We're going to tackle the negation now. Now this one, it's interesting. I think we can take a slightly different approach, but notice negation is actually recursive too. It calls itself, but I think we could say negation parser equals, I think we could say there are 0 or more nots followed by a relational, which is wrap old self relational. And then we're going to have to pipe it to a make unary expression of some sort. Now, this thing, let's see, we'll make that function, but the unary is going to have to check the float type and then wrap a knot around it for each one. Okay, so I guess let's kind of duplicate this one. Let's rename this to form binary expression. How about form numeric binary expression? I don't know. There may be a way we can avoid that. It's like we need a new combinator or something. But okay, let's take this. We'll adjust this dramatically. Form unary expression. Okay, and we're going to be given tokens and an expression. Tokens array of expression. Okay, remaining. All right. Let's let knots and expert equals that. Tokens expert. Okay. So this thing basically, if the knots count as 0, we just return tokens expert. So if there are no knots, then the expression by itself is fine. If there are knots, um, well, strictly speaking, um, the last knot is the one that applies to the expression first. Okay, so if you say not false, the way that's really parenthesized is this. Okay, it's not false. Okay, now with I may be being pedantic, I guess, but you could imagine a situation where you have different unary operators that apply, and so the the knots, let's call this operators then. Ops, an op for operator is super common, so we're going to use it. um, it could, like, you could imagine having a unary plus or a unary minus or a not or something else. Okay. In our case, we're dealing with not, but it could be anything. You could even imagine a absolute value, like unary plus usually means ignore me, but you could imagine it being absolute value. And, the negation of an absolute value is different than the absolute value of a negation. So the order will matter. All right. So if the operators are empty, then we just have the expression. We don't have to worry about it. I think what we need to do, though, is take ops dot reversed. I mean, this is probably okay. Ops dot reversed. And is this a reduce? I guess it is. Yeah. Reduce. We'll take that expression and then we'll build an expression op1 of, well, this is result expert in op1. No, it's not. It's just the ops. Oh, no, reduce. Yeah, it's result expert. Op1. How about that? Okay, and this is expert so far. And the operator. Okay, so let's apply op to expert so far. Okay, I think that's more like it. Okay, take the ops, reverse them, take the last operator, take the expression, and apply the last operator. Dot type. Okay, apply the last operator. First, and get its type is like and or not, and so on. Okay, that whole thing is our return value. Let the result equal that thing, and return dot success result remaining. Okay. Yep. Okay. So pull it apart. If there are no ops, then you just return the expression. If there are ops, I guess here we need to enforce the float type, right? It was float. Require float type on there. Okay, so let's do that. Okay, if the count is 1 or more, then we got to say guard Really, it's the same. The expression type has to be numeric at that point, else return failure. And I think let's do remaining dot start index -1, and the failure is the message is, I think it's numeric type is required. Yeah. Okay. That's my form unary. Okay. Negation parser. Let's put that up here. Negation parser, form unary expression. This goes to negation parser. Okay. Was never used. Okay, good. And run. I don't know, a little bigger step than I prefer, but okay. Handle negation parser, or okay. Now relational is also a little different. Relational says matching types, so I can say A equals B, or I can say $A equals B dollar, but I can't say $A equals A, or $A equals X, or anything like that. Okay, relational. Whoops. That's the one that goes. Whoops again. Now this is going to be similar. Okay, it's going to be similar to our other one. I think it's just going to be different enough. All right, move that. So relational. And we're about halfway down our stack here. Here's relational. Okay. So relational is parser is, well, it's wrap old self sub expression separated by, well, what's it separated by? It's separated by relops. Okay, that's a little different, and then this is a little different. Okay, so relops, I don't know if we have a match for that. Well, let's find relops up here. Okay, here's all these. We got match. Where's match? Match token type. We don't have a corresponding example for this. Let's make one, another basic parser. Oops. Okay, match type of token type. This is really, I think, array of token type, right? Is that what relop was? Yeah. One of this array of token type. Okay, didn't find expected value. It's probably not important. Message $0.type. It's really like type. Sorry, one of dot contains this. Hopefully that type is illegal. Okay, so if we match one of, and I think I want to even do this. You know, let's just make it call it one of and be done with it. One of, okay, and this is tokens. Okay, one of tokens, didn't find expected value. If none of them work. Okay, and if the tokens contain the actual, then we're good. Okay, and how's that down here? Okay, so tokens, one of relops. Okay, and we need a matching, a make for this, or a form. Form matching binary expression, I think is what we'll call this. And really, this is the only one that uses it. Okay. I don't know. We probably can. I'm looking for a way to simplify this, but it seems like I should be able to take my whatever's coming in and check all the numeric stuff, and then do it again to produce the expression, because that part's mindless. I mean, it doesn't do any error checking first. Okay, let's make it work, and then we'll deal with it. Okay, so it's coming in with the same thing. Well, actually, it's not. Let's go back down there. Okay, this one is funny in a couple ways. So it's not really a separated by. It's really optionally followed by. We don't let you say if $A equals B equals C dollar. So, yeah, I guess I would say it's this optionally followed by, or followed by optionally relops and an expression, a sub-expression, which is a wrapold. Okay, let's format this so we can read it. Okay, so wrapold, self sub-expression, okay, followed by optionally a relational operator and wrapold of sub-expression. Okay, so there's no loop here. There's only an if. If there is a relop, then we expect a sub-expression, and then we require the matching types. Yeah, that seems like that can be done at this level, and then we've got to form the operation. Okay, so I think the whole thing is going to pipe into our make, form matching binary expression. Okay. Cannot find in scope. What does that mean? Oh, it's not try, it's let. Okay. Cannot convert wrap old. Yeah, the type is totally messed up. Okay, let's get this out. Put that up here. Wrap-old sub-expression, this complicated thing. It would almost be easier. It would almost be easier to use the approach we took here and then let the checking routine make sure it's only got a single comparison. Again, that's kind of a future improvement, I guess. Let's get down to form matching binary. There's no form matching binary. Okay. What was it getting? It was getting an expression and then optional token expression. I guess I can split this a little. Okay, so expression and then a token expression optional. Okay. Expression followed by a token optional expression. Okay, so that's this expert op token expert token expert. Okay. If token expert is nil, I could probably say this one as a guard. Guard. Let. Normally do it like this, equals token expert. Else. Okay. Meaning token expert becomes a declaration of a non-nil token expert from here down. Okay, return success remaining. We got expert. So yeah, if there's no token, meaning no relational operator, then just return the original token. Don't check anything about it. Okay, and now we need to make sure. Okay, I guess we gotta get expert 2. And I'll call this expert 1. Okay, so if this is nil, then we just have expert 1, return it. Okay, otherwise we got expert 2. Okay, these two must be matching. So guard expert 1 dot type equals expert 2 dot type, else it's failure. And we got to find matching somewhere up here. We had a match function type mismatch. Okay, that's pretty accurate, I think. Okay. For matching, okay. Else, if the types aren't equal, well, let's return failure. And again, we had to kind of figure out the place to do it. I'm going to say remaining dot start index -1. Again, this is a place for improvement in the future. Failure, and it's type mismatch. Okay. Now, let's let result equal this. Okay, so if this succeeds, then we'll take token expert1, expert2, and return to result remaining. Okay. Without a conceptual type, token expression. Why did that work up here? Well, it's expression dot up too. Okay. All right. Take it from the top. Okay, we've got an expression and an optional token expression, like A equals $B. If the token expression is nil, then we just have A and we return that successful expression. Otherwise, we'll pull out expression 2 and token, check that the types are equal. Let's look at our matching and make sure there's nothing funny there. String types, left type equal right type. Okay, cool. Down here. Matching. Okay. Type equals this, otherwise mismatch. If the types are the same, then we're going to return the token type. The two experts form it into an expression and the result. Okay. What do we have in our parser? We're not calling relational parser yet. That replaces the wrap old. Okay. And this should just work. Okay. Again, the steps feel a little big, but if they keep working, that's good. So this is make new relational parser. Okay. And next one down is sub-expression. Say delete this, move this, copy this, and move. Okay, on sub-expression, that's very much like our and expression, so not much to worry there. Sub-expression. Okay, now we have the plus or minus. Okay, so let's sub-expression parser equal. We'll do a wrap old term separated by, and I'll need to know what they're separated by. And this is match. I think I need an array like this, just like I had rel ops. Let's add ops. Token type. Plus and minus. Okay. Down here. Match this is one of, whoops, one of add ops. Okay. And then we feed this to make form matching, nope, form numeric binary expression. Okay. And put that up here. Okay, sub-expression only references here, so let's sub-expression parser. Should pass. And I suspect it's that same message. Numeric type is required. Yes, that's actually a better message. Is required. Yeah, I was wondering why that one didn't show. Okay. Next level down, we'll get a couple more. Make new parser sub-expression parser. Okay. Next is term. All right. So expression called it. Okay. This is again similar. Let's see. Let term parser equal wrap old self power separated by one of mult ops multiply ops piped to form numeric binary expression. Okay, and multiply ops is going to be this thing. It's require float, builds op2s, so again it's identical to the others. Multiply ops. Yeah, I was going like y. I'm going to rename this rational ops. Okay. And something's still marked. Term parser is not being used yet. Okay. Term parser with add ops. This thing calls power with multiply ops. Okay. Should be a couple more messages on the type mismatch thing. Numeric type is required. Yep. Let's see, make new parser term, parser. Just clean up a little. Okay. We're next looking for power. Okay. And again. Okay, this one. Oh, interesting. This is really 2 and 1. I don't know that that's I don't know that that's great. Let's define. So what they're saying is power comes first. So -3 to the 2 is -9, not -3 squared. Fair enough. But I think this thing is going to be just like our unary, except we're calling power in it. So let's let the power parser. Let's deal with the bottom first. So this is a RAPLed factor. Getting to the bottom. Okay. Separated by. Now this time there's only exponent. But I think like before, it makes it all the same if it always returns the thing. So let's return it. Exponent is factor repeated, and then it's our normal form numeric. Okay. And then the minus parser, maybe it's the negative parser equals. Now this is, we did this before, dot match minus followed by a power parser, and then fed to a form unary expression. Okay, and the unary expression enforces this if there are any, otherwise it returns the whole thing. Okay, so I think this is the way we're going to do it. Put this in up here. And this is me breaking it down a little more than it was. I think that's a good thing in terms of the grammar. And I feel like there should be some other way to simplify some of this. I mean, in principle, we could write a little matcher that takes these three things, but I don't think it's that hard, and there's enough difference. Okay, but notice this one, match not and relational parser, match minus and power parser. Okay, very similar. I guess if I were going to put in that work, I'd probably just go out and define a parser that can do precedence and associativity and be done with it. Okay, but negative parser, this is really power. Now power is negative parser plus power, so negative parser calls power parser. So this one is really calling negative parser. Okay, And again, I think we're going to see some error message changes, but it should fundamentally work. 2 failures. Okay. Interesting. It's only showing the one. Okay, but it's numeric types required. Okay, that one's good. The negation. And then the exponent. Good. Okay, make new parsers, negative parser and power parser. Pushing my tablet thing is sliding. It makes it hard to work. Okay, so we want to do factor. This is done. Okay. Now, factor is different. So factor is either parenthesized expression, numeric factor, actually, or string factor, variable, predefined, or user-defined. This one starts with a left paren. This one starts with a number or a string. This one starts with a variable name. This one starts with a FN. And this one starts with, this one starts with a reserved word, and this one starts with an FN. Okay. This back here. Okay, so this one's, it's a little more complicated. Factor. Yeah, there we go. Nice mess. Not mess. It's just there's a big out factor here, which is okay. All right, so let factor parser equal. Well, this is either a. Oh no, we got to be careful with this parenthesized expression. Okay, it assumes the current token is a left parenthesis when it parses it. So we'll have to be explicit, I think. So I think we're going to have to be a left parenthesis and sorry, we don't need the paren to make sense of this, and a parenthesized, a wrappled parenthesized expression. Okay. Left paren and a parenthesized expression. Okay. Or numeric factor, expression number. That, I think we can just say match dot float. Expression dot number float value. Yeah, again, it's a little different. Okay, so if it's a number, if it's a number, then we're going to convert it to expression dot number with $0 dot float. Okay. Or it could be an integer. Okay, fit that on one line. Yes. Match integer, which is the same thing. Okay, so if lepren number integer string $0 dot string. Okay, that's that. If it's a variable, let's go to this one. Okay, good. Why can't I keep this navigation thing in my head? Oh, there's Control B too. What was the bracket thing? Jump to last destination. There we go. Okay, so variable, it assumes we got the variable there. Match variable and wrap old variable. Okay, these ones like that where we're checking it there, I feel like that's it's not quite expression and target type. Token type is variable, return variable. I guess wrap old expression target expression and satisfy token target be equivalent. What else we got? Predefined. This one we could ignore it. This one we can't. Wrap old. I'm just going to turn $1. Is that going to work? Okay. $0 is the variable, $1 is the result of this. We want to keep the result of this. This is almost, well, it really is peak of variable. Maybe that's the way to go. So you peak, make sure it's a variable, and then just return wrap old. That sounds better. Parser has no member variable. Parser has no member variable. Why is that a problem? Peak variable. Oh, it's called something else. No. Top variable is token type. Oh, peak of match variable. Okay, peak of match variable, then match the whole variable as it comes. I hope I'm doing the right thing. Okay. I really wish I could do these one at a time. Predefined. Let's see. We're okay. Still, we're not using it. So let's simplify this. So this one, if it's predefined, we're going to call this with the token string and the token result type. Well, the token is what it is when it gets in there. So we can get the string and the result type from the current token before we do anything. So let name equal token dot name string and type equal token dot type. Okay. Let's take this out and this out. Token type has no member function. That doesn't seem right. Token type has no member function. Okay, what is... Oh, dot type somewhere. Type token dot type. Is a token type. Oh, okay. Token type. Result type. What do we pass in? Let's make sure. Token dot result type. Okay, good. Token dot result type. I think token dot result type here. That type is that. Okay, that looks better. Okay, this should pass. Now we're ignoring these, so let's not pass them in the first place. Should be a red line somewhere. Don't pass them in. Okay. Now what's this? Name is guaranteed to exist. Okay. Good. And one more spot. What's up? Okay, good enough. Okay, so make predefined function call, take no arguments. It's already got access to the token. Okay. And now we can peek on predefined. And wrap old predefined function call. Okay, that's that one. And then function, user defined function call. Okay, and otherwise, we get an error, expected start of expression. Okay. Put this up in our expression parser. Okay. And call it here. Vector parser, match exponent. Okay. It's kind of a big change. Okay. I'm thinking maybe I need to do a peek there too. Parse. Characters end line. I think I broke the pattern. Let me do a peek match here. So I only wanted to match them directly when I'm prepared to process them directly, like these ones. The other one should do peek match. Right. In the end, I think that'll go away once we get the whole expression inlined. All right, so make new factor parser. Okay. We'll work on parenthesized expression next. And we did factor. We also did numeric factor. And we haven't done these others because they all have more calls. Okay. So let's go down to parenthesized. I really want to get rid of those. Parenthesized expression. Okay, so let's say parenthesized parser is, well, it's match.leftParend. Ignore that, don't really care. Expression and match right paren missing. I think one too many. Right paren missing thing. Okay. Match left parent and expression and match right parent missing right parent. Ampersand greater requires token and throws. Nothing throws expression input be equivalent. I don't see it. We're ignoring the left hand thing. Oh, yeah, we can't do just expression. We can do a wrap old. Wrap old self expression. Use that recursion. Okay. And that should be it. Okay. Back up here. Okay, expression parser. So this becomes parenthesized parser because it's got the left parent already. Now it's okay that it matches because it's dealing with the whole thing. Parenthesized parser. Okay. Initialize. Yep. Good. And now we get that little trick. Instead of calling wrap old expression, let's call expression parser. And notice because we did the bind, even though we don't have the function yet, we've named this thing so we can call it recursively. All right, it's not calling it in this case, it's defining the grammar of it or whatever you want to say, but it can access it. All right, so before I made that change, when you came into a parenthesized expression, everything around it was parsed as a new style expression parser. You get inside the parentheses, and it used to call the old style expression parser. Now it calls back to the new style parser. Okay, so that's a nice step forward. Okay, yeah, pretty quick. Okay, so parenthesized is done. Let's do variable. Variable. Okay, down here. Variable. Okay. So now, let's look at our factor. Variable is the token type, so we're matching variable. Okay. Match variable. And this one's going to be a little uglier. Okay. Require variable, expected variable. Okay, let's put that in. I think that's actually for the lead case. Okay. Should be a variable parser. Okay. Then we got some semantics. The name and the type. This is major, isn't it? Okay, so I can turn the variable into its name and type. Let's do that. I don't know. I may be tearing it apart a little bit unnecessarily, but if I do that and I pipe it to I want to make a variable. The name is $0.name string, and the type is set string dot last equals dollar string else dot number. Okay, I'm gonna note this. Oh, I'm not even current here, am I? We did this. Convert expression, pull from token. Make variable tokens know their type. We'll have to see on that one. Okay, dollar string at last, this, that. Okay, that's all this stuff. Okay, so this whole thing is the variable part. Now, it's optionally followed by a left parenthesis, so this is optional. Match left parend. Actually, it's optional a whole bunch of stuff. Match left parend. We'll close it. Okay, so if you have a parenthesis, then we're going to do expression, comma, expression, and build them into a list. Okay, so this is followed by, well, let's put that down here, followed by expression, expression parser separated by commas. Okay, so this is array access. And we'll gather all those. Okay, followed by right parent. Okay, so you match the variable and you're going to form an expression from it. Let's see if I can kind of make these look more like. Okay, match the variable, form an expression that represents the variable. Otherwise, we've got a left parenthesis, a series of expressions separated by commas, and a right parenthesis. Okay. This whole thing, oh dear. I'm missing something. Okay, this and optional that. Okay. Now I think I'm in trouble. This returns. Oh no, I've got the variable and an array of expressions. Okay, so now given those, yeah, we're not doing anything fancy. We're just producing this. Okay, so we're we're gonna do a function on it. Okay, the function is name, type, and expressions. Well, this is the variable and the expressions in. Okay, if okay, if the variable is like it is, I don't think I can access it directly. Variable dot, yeah, that's the problem. Its type is now expression, and I have to go through and check that the type is this and that. I'm going to make this return a pair instead. Let's just return the name and the type. Okay. And then this is really name type and expressions. Let name type equal name type. Whoops. Name type. Okay. Now I have the three pieces I need. Okay. So if expers.count is 0, that means no, this term was empty. Actually, is that right? I don't know. It's optional. Can I do it like this? We're going to return success with a variable of name and type. Okay, that's what we did down here. Okay, if cannot infer type with multiple statements. Okay, still have to do my return. Okay, if the expressions count is not 0, then I'm going to return success with dot whatever the bottom thing is, array access. Okay. Return result, which is expression. Okay. This is type dot string. Yeah. Oh, I don't need the dot success. Oops, just the variable name and type. Again, it depends. We have two kind of pipeline things. One with the ampersand that does the fancier stuff, and then one with the no ampersand that just converts it. Okay. Yeah, I was wondering about this. Expers is really expers optional. Guard let expers equal expers. If there are none, if there were no expressions, then return variable. Otherwise, return array access. Okay, I think that's cool. It's more complicated than you'd expect because it's not just a variable, it's the whole array expression thing. Let's go up here. Variable, where'd it go? Lost my new parser because I had to move it down, right? Okay, factor, there we are. Variable parser. Kind of a bunch, but left paren expression separated by commas. Yeah, I think it's accurate. Parenthesized expression. Where's variable? This is variable parser. And the peaks go away because the variable parser deals with it. First thing it does is check that it's a variable. Okay. All right. Okay, next is predefined. Okay, another one with a lot going on. Oof. Okay. Trying to think where we are. I've only got a few minutes left here, so all right, so we're going to match the name and the type. Predefined function. Okay, so yeah, we know it's predefined and we've got the function type. Golly, it's kind of the same. We got an expression separated by commas. And then we got to do a bunch of type checking, more type checking, and that. Okay. Yeah, I mean, it's all kind of mechanical transformation, but a little error prone. Okay. So this is the predefined function call parser is. All right. Well, what are we matching? We're matching a predefined. Yep. Match predefined. Defined. Okay. That's the the name, like char dollar or rand, for random. Okay, we match that function name. We got to get that string and result type. We're going to use those. We're making sure the type is function. Okay, that we can look at later. All right, it's got to be followed by a left parenthesis. Well, keep that. Ignore the left parenthesis. Okay. Followed by a comma-separated list of expressions turned into this. Okay. And this time we need both. So we need expression parser. Separated by commas that we don't need to keep. Okay, and those we'll call expression parser. Then, then we need the right parent. Let's get that in first. Oops, that's matched comma. Followed by match right parent. Okay, so that's the syntax of it. But there's more to do. Okay, so this internal error function has non-function type. Okay, I mean, yeah, we got to do this. I guess I should put all this in somewhere. And maybe this is deserving of a function. Okay, we have to check this. Yeah, I don't think we're going to finish this one today. We're going to fill in the expressions, type check them, and then return a predefined. Okay, so let's pretend there's a function that does the work called form predefined call. And let's start defining that. I guess one of these like this. Yeah, form matching. I'm going to put it down where we're working, and later we can sort these things out a bit. Okay, form predefined call. Predefined call this. Okay, what are we taking in? Well, we got to be taking in a token. And then a bunch of expressions. Type is token, array of expression. Okay, token and expressions. Remaining of slice. Okay, and let's just return we're gonna hard code it for a minute here. Okay, predefined. Let's do token.name, token.string. I don't know if I have to put that there. Token.string. We'll get to do a let. Token.string. It's a parse result, so let's do a success. Predefined token string, result type, and remaining. Result type is, well, let's just hard code this too, number. Okay. And that should be fine. Okay. And this should run. We're not calling it, so no harm. Okay, let's pull the parser up top. Variable parser, parenthesized parser, predefined function call. Predefined function call parser. Okay, and I expect a number of problems, but I want to get here and stop for the day. Okay. Oh yeah. Okay, a blow up too. All right. So return type, printable expression char dollar is not equal to predefined char dollar number 4 type string. So the type got messed up because we hard coded it. Should have been an error. We didn't detect it. Type mismatch. Yeah, we're not running any of the semantics yet. Okay. This is a good place to stop then, because we'll know there's plenty to do tomorrow. We will stop here. Tomorrow we'll pick up at the same time as today's, which was 1 to 3:30 p.m. Eastern time, or 6 to 8:30 p.m. UTC. I think we've made a good bit of progress. We got through most of the parsers, not quite all. We're on this one. But we've just got these last two. They both have some different error checking and stuff to them, so that's okay. But once we finish these last two, we can go ahead and clean up a lot of stuff. So I think that's what I see on our plate tomorrow. We'll finish predefined, we'll finish user defined, and we'll clean these up, and then probably create an expression.swift that holds these, and go from there. So thanks for joining today. Hope I catch you again in the future. Take care. Bye-bye.